Our next topic is prime factor decomposition. First of all, you need to understand what are the prime factors. A prime factor is a factor which is also a prime number. All natural numbers except 1 can be expressed as a product of prime factors. For example, 21 equals 3 times 7, where 3 is a prime number and 7 is a prime number. 64 equals 2 times 2 times 2 times 2 times 2 times 2, and all these 2 are prime numbers. 24 is written as 2 times 2 times 2 times 3. So these 2 and 3 are also prime numbers. To find prime factors of a natural number, we use factor tree method. And what is the factor tree method? Split the original number into two branches by writing a pair of factors at the end of the branch. If there is a prime number at the end of each branch, we have constructed a prime factor tree. If not, then repeat the process until we get prime numbers at the end of each branch. Here we have a worked example. Find the prime factors of 56. So split 56 in two parts and write at the end of branches like this. Here we have 56 and we divide it as 2 times 28. Now 2 is a prime number but 28 is not a prime number. So we will repeat the process and make a circle around 2. Now repeat the process for 28. Now 28 is 2 times 14. 2 is a prime number, so we made a circle around it, and similarly. Now continue for 14. Now 14 is splitted. 14 is 2 times 7, where 2 is a prime number and 7 is a prime number. So as all the end numbers are circled, so it's completed. List every number that has been circled. So 56 equals 2 times 2 times 2 times 7. Write any repeated numbers as powers of the original number. Here we have 2 for 3 times. So 2 raised to power 3 times 7. Prime factorization can be used to find if a given number is a square number or a cube number. A number is a square number if all the indices in the prime factorization of the number are even. And a number is a cube number if every index in its prime factor decomposition is a multiple of 3. Here we have a worked example of prime factor decomposition. Find the smallest value of p. Pn equals k, where p is an integer and k is a square number. N equals 2 raised to power 4 times 3 times 7 raised to power 5. Substitute n equals 2 raised to power 4 times 3 times 7 raised to power 5 in this formula. Pn equals k. So p into the value of n equals k. So 2, 3 and 7 are all prime numbers. So for this number to be a square number, all the indices should be even. Where power of 2 is 4, which is an even number, we need to make power of 3 is an even number and power of 7 is an even number. So smallest possible value for p, it will be 3 times 7 into the value of n, which is 2 raised to power 4 times 3 times 7 raised to power 5. Now if we multiply them, the answer will be 2 raised to power 4 times 3 square times 7 raised to power 6. Now this is a square number. Okay, so the smallest possible value for p is 3 times 7. So p equals 21. Next is highest common factor. The highest common factor of all the given numbers is the largest number, which is a factor of all those numbers. To find the highest common factor of given numbers, find prime factors of the given numbers, then list all the prime factors of the given numbers, then multiply the common factors together. Worked example of highest common factor is find the highest common factor of 84 and 105. So find prime factors of 84 and 105 by using tree method. 84, we divide 84 in two parts, 2 and 42. 2 is a prime number, so we make a circle around it. Then we divide 42 in two parts, 2 and 21. 2 is a prime number, so we made a circle around it. Then 21 is divided in two parts as 3 times 7. Now all these numbers are prime numbers. So similarly for 105, 105 is divided in two parts, 5 times and 21. 5 is a prime number and 21 is divided into two parts, 3 times 7. 3 is a prime number and 7 is a prime number. Now list all the factors. 84 is 2 times 2 times 3 times 7. 105 is 5 times 3 times 7. Now multiply the common factors together. Common factors are this 7 is common and this 3 is common in both prime factors. So 7 times 3 is 21. This is the highest common factor of 84 and 105 is 21. Next is common multiple. A number that occurs in both of two numbers times tables is referred to as a common multiple of those two numbers. For example, the multiples of 3 are 3, 6, 9, 12 and so on. The multiples of 5 are 5, 10, 15, 20, 25 and 30. So common multiples of 3 and 5 are this 15 is in both and 30 is in both. So 15 and 30 are the common multiples of 3 and 5. There will be many. Least common multiple. A least common multiple of all the given numbers is the smallest number which is a multiple of all those numbers. To find the least common multiple of the given numbers, find prime factors of the given numbers, list all the prime factors, multiply the common factors and non-common factors together. Worked example of least common multiple. Find the least common multiple of 56 and 42. So first of all, list all their factors. Factors of 56 are 2 times 2 times 2 times 7 and 42 is 2 times 3 times 7. Now multiply the common factors. Common factors are 7 and 2. So 2 times 7 is equal to 14. Now non-common factors, which are 2 times 2 times 3 equals 12. Now multiply the common factors and non-common factors together. So we need to multiply 14 times 12 equals 168. Now this is a least common multiple of 56 and 42. Here you have an exercise. Question number 1 is, find the highest odd number which is a factor of 60 and 90. It's a 2-mark question. Question number 2 is, find the lowest common multiple of 20 and 24. It's a 2-mark question. Question number 3 is, write down all the factors of 1028. It's a 2-mark question. Question number 4, some information is given. Use this information to write this number as a product of its prime factors. It's a 2-mark question.